Okay. Are you able to see my slides, Dr. Karen?
Yes, I can see.
Okay, thank you. Okay, so without further delay, let me start with my presentation. So good evening, everyone. So today, my presentation or sharing will be on fuzzy logic prediction. So I'm currently working with Sagi University, and talking about fuzzy logic prediction, today our sharing section will be on fuzzy logic prediction for research work to reduce the laboratory experiments and how it can benefit the researchers during this pandemic. Okay, so the outline of our sharing section today will be on the introduction of fuzzy logic. What are the fuzzy basics, daily usage and examples, and then fuzzification, and then how it was implemented in research work, and also how it benefits the researchers during this pandemic. Okay, so let's go to the first one, which is the introduction. So we have to thank the guy on this picture here. He is Lutfi Azadeh. So he found this fuzzy logic. He implemented it in 1965, and he feels there's an important due to its present in many consumer products. So basically, he said how we want to satisfy our consumers. So this is an excellent tool for representing complex process when there's no simple mathematical model. And this is actually an integration of various type of knowledge, which is including experimental, numerical, recommendation, and also the suggestion data within one common frame. And actually it leads to higher degree of automation for complex type of process. And this fuzzy logic mainly is used in control system related fields. So control system, if we see, it is used by mechanical researchers, electrical researchers. So basically this control system, besides these two mechanical and EE, it is also being used by other field where whatever system that is being automated or controlled. Okay, so talking about fuzzy basic. So if we see here, what we know about logic is the one that we have or we have seen earlier is a logic base that is on two truth, which means we have true or false. So but at certain times, this true and false not really enough. It's inadequate when describing a human reasoning. So what is that human reasoning? I will show some examples later. So this fuzzy logic actually uses the whole interval between 0 and 1. If a logic is actually from 0 or 1, this fuzzy logic actually it has a interval. So from what we can see in this graph, if we see for the Boolean logic, it is actually we have either 0 or 1, where else for fuzzy, you can see there's a nice curve here that is showing that it can be between any range. Okay, so to be more examples, I mean, that is close to us. So if you want to see how this Boolean and fuzzy is different, the difference between them. For example, if I'm taking, I'm Shamini. If someone, I'm going to ask someone, is Shamini a honest person? So if I give them a Boolean logic answers that they have to give me, it can be either true or false, yes or no. But in this case, let's say if I'm talking about the same question, but I'm using a fuzzy logic, then I can have various answers. For example, the person can give their reasons of selecting this output. That means extremely honest, very honest, sometimes honest, or extremely dishonest. So they can have a range of, I'm going to put into 4 categories. I'm going to put into 6 categories. So that's what fuzzy logic means here. So this is a very simple example that makes everyone understand, okay, that's the difference. Okay. So like I said earlier, this daily usage or examples that we can see is like when we are talking about when the sun is relatively getting hot compared to the day before, today it is really hot. So how do we say how much is getting hotter? So depends on the temperature that we're going to check. Or if we're going to say Chamonix is tall. So tall in what sense? For us, we can always put a range. Okay, small, medium, high. We can interpret the small, medium, high with our own values. And another example is my car is fast, but yours is slow. How do we compare that? How do we say reasoning for this? And another example here is the room temperature is cool. When talking about cool, we can also put the range. For example, if I want to put up to 5 range, low, low, medium, medium, high, medium, and high, I can arrange according to the temperature. I can put, let's say 15 to 17, 18 to 21, 22 to 25, 26 to 29, 30 to 32. We have a range. And this range, it depends on the researchers themselves. Okay. So next, let's go to fuzzification. Fuzzification means we are changing something into fuzzy logic. So fuzzy converted this numerical number as a synthetic word with a range called linguistic value. So we're going to have a linguistic value for these numerical numbers that we're going to use. So like the height is converted to small when we are having 4 to 5 uh, feet, and then the medium will be 5 to 6 feet, and the high will be 6 to 7 feet. So this is depends on the researchers themselves. So how we gonna use it, I will show later. Generally, the input and output variables are defined as linguistic variables. So the input that we're gonna put and also the output that we're gonna get, both will be as the linguistic variables. And this each linguistic variables will have their own values that may be expressed as a synthetic language, words or sentences. So these linguistic values that we're going to see here are the words that we're going to use, like small, medium, medium, high, low, this kind of terms that we're going to use. So in this fuzzy logic, I have implemented in my research work back in 2017, and I find it is quite useful for this current pandemic that we have gone through. So when I used this in 2017, I had medical issues that I could not go to the lab. So I have finished most of the research work, but I had a small part that I wanted to find out the best result that I can get from certain research work. So what I did, I used this fuzzy logic prediction method, and I was able to get the values that I can achieve in the lab. So today, I would like to share one of the research work that I have done in 2017, and the topic was on a fuzzy logic based prediction model for fracture force using low power fiber laser beam welding. So from the title is actually, if I want to explain in a simple word, it's actually two materials are being welded together using laser beam welding, and I have to measure, my output is to find the fracture force. So that means I have to see how much it can withstand the, how much force it can withstand until it fracture. So basically that is the idea of it. So in this experiment, in this study, actually a single-sided welding of titanium alloy and a nickel-based alloy. It was used as a T-joint configuration. So when you imagine T, it has a configuration like a T. So it was carried out using a continuous wave, low power fiber laser. So this experiment, it has few parameters that influence the force, which is the laser power, welding speed, and the overlapping factor. So with these three parameters, we're gonna see how it's gonna influence the force gonna influence by influenced by these three parameters to fracture the samples. Fracture means we're gonna break them into pieces. So the method here is, this was the material, the titanium alloy with this 20 mm times 20 mm times 0.5 mm thickness with nickel alloy in Cornell 600, 20 mm by 20 mm by 1 mm were laser welded on a single side of a T-joint configuration. So talking about T-joint configuration, and you might think that why the material is very thin. Okay, this is due to it's a very low power fiber laser. Like I have mentioned earlier, it was only 300 watt. So normally this in welding, we use at least 1 kilowatt. So this was a very low power welding, and for that I have used a thinner type of sheets. So then they were welded with the materials where one of it is skin, another one is stringer. So I have a picture here to show. This is the figure 1, shows the schematic diagram of the welding experiment setup. Like I said, this is the titanium alloy. So this is the skin. Whatever comes underneath is the skin. Whatever that stands like a T, that's the stringer. So if you see here, this is like the opposite T. The T is a bit slanting. And I have welded at this area. So this is actually a single-sided weld. So this single-sided weld is normally used for aircraft. And we want to see how strong it is for certain applications like the seat belts, you know, and then also at the certain chair or the seats that we're gonna weld together to the either the aircraft or the car, this kind of application. So this laser beam could not be moved, so that's why I have to rotate in such an angle that the laser beam hits straight to the welding area. So once this is done, then I have designed a jig to pull the welded sample towards down. Can you see the force? And from here, I'll be able to fracture the sample. So that value, the fractured value, is the one that I'm going to predict. Okay. So now for this fuzzy logic, what I have done is I have to put in my inputs. So in my studies, that means, like I said earlier, I went to the lab and I have done certain experiments for me to build up this model. So the parameters that I use here is the laser power, welding speed, and overlapping factor. So the laser power is, of course, when the machine is 300 watt maximum, we can't use up to that. So I have used 3 levels, which is 250, 260, and 270 watt. Whereas the welding speed, I only had 2 levels, which is 40 and 50. And the overlapping factor here means how many, when we are looking at the beam area, the laser beam, how much it is overlapped to another beam. So it has the calculation in the system, the laser welding machine itself. So I have set up to 30, 40, and 50. And using these input variables, I have designed the fuzzy model. So we normally we use the Mamdani model where, like I said earlier, I have 3 inputs and my output is only 1, which is my fracture force. Then I have the input membership function type, which is triangular and Gaussian. The output membership is triangular. So later I'll come to here why we call it triangular and Gaussian. Then we have the rules weight. Rules can have, you can have a few types of rules, but normally I use only rules number 1. And the number of fuzzy rules. It is best to have the more rules you have, the more accurate sometimes you'll get, but 18 is sufficient. And then you have some other methods that you're going to use, that you're going to take the minimum values of N method and the implication method, and also the aggregation method. And finally, the defuzzification method. So normally these four normally are fixed. Only the one that's going to change is the top 5 that we have here. So going a bit further, so like I said earlier, this is my laser power. My laser power has a range of what I have fixed earlier, 250 to 270. And then my welding speed, my overlapping factor. So this is all are my I, which is my input. And this is my fracture force, which is my output. So when I'm having about my output, I also have to see under which category do I see as low, medium, and high. So if it's under 240 until 260, but the welding is 40, then I'm gonna say it if my third factor, which is the overlapping factor, is within 20 to 40, it will fall under low. Same goes to how about medium and how about high. So all these parameters, all these values is fixed by me. Okay, I'm the one who fix it. So I'm gonna put, okay, I'm gonna consider this is as low, this is medium, and this is high. Then from here, actually, we can see that for welding speed, actually, I'm using a Gaussian speed. So a Gaussian membership. So if you ask why is it for welding speed is Gaussian, because it has only two values. Sorry, only two values. So in fuzzy logic, when we have more than two, then we will consider on triangular membership. That is more, you can have more accurate results. So normally I have used this 18 experimental data and rules, which will help me to predict the rest of the experiment. And this aggregation process actually used to analyze the implication of the result generating in a single fuzzy set. So all these we're going to put into a model, which I'll show later. And this linguistic fuzzy set of laser power, welding speed, and overlapping factor can be defined like what I have said earlier. Okay, so this is my membership function that I have said earlier. So can you see the triangular shape? This triangular shape is actually the membership for laser power. So when we have more than two, then we can do it as a triangular pattern. Whereas when we have two, then it is best to make it as a Gaussian, or else the pattern will not be so accurate for this kind of studies. So same goes to this overlapping factor. Since I have three, then I've used a triangular method. And finally, I have got my output variable force in this form. So you might ask, what is this FF1 until FF14? Okay, when I have fixed this low, medium, high, when my range of input falls under low, I would put my fracture force as low. So the values that I have, I'm going to make it into a triangular variable, output variable as well. So with this membership, we can actually estimate how the pattern of the fracture later. So these are the rules that I have set for this study. So basically, if we see here, like I said, we have 18 rules. We can have even more rules. And these rules are actually indicating what is the value that we have got. Like I have mentioned earlier, we need to have a certain data to set up this fuzzy logic. So after we have the certain data, then only we can do the prediction. So somehow in your hand, you should have some data to implement this. So this was my testing data that I have tried. So like I said earlier, this was I had 14, sorry, I had 18 data that I have put as a rules. So from there, I am predicting what will happen if my laser power is 255 and my welding speed is 45 and my overlapping factor is 50. If you check in my previous table, in my experiment, I only tried 250, 260, 270 with 40, 50, and with 30, 40, and 50 overlapping factor. But if I'm going to try something in between 255, so this will be able to show me the results that I'm going to predict. So to see that whether my data is valid or not, so what I have to do is to run back this experiment when the lab is open again. So this is to verify that our model works. So that means once we have verified this, we will be confident that whatever prediction you do, it is the value that you're going to get. So using this, when I tested it out, so this is my prediction. The one in the green is my prediction, and the one in the blue is the values that I have got. So I have done 3 experiments and took the average result for all the 6 testing that I have mentioned earlier. From here, if you see the error bar, it is within the range. And if I'm going to plot the correlation between the experimental and the fuzzy logic predicted fracture force, actually I'm getting the R square is 0.9849 for the training, and for the testing I'm getting 0.8404, which the most of the literature review says if you have R square below than 0.75 is considered good. That means your model is fine. We can use it. So this is the control surface of the fuzzy interfering system. And from here, we can see at the laser power and the overlapping influence on the fracture force. And then for the B, we can see the laser power and the welding speed on the fracture force, followed by for welding speed and overlapping factor on the fracture force for the image C. So from here, we should be able to see that how it is influencing the output, which is our fracture force. So the main important thing here is when we are doing this testing, if our results are close to our predicted values, then we can be confident that we can use this model for any prediction after this. That means whatever range that I'm going to have from 250 up to 270 with whatever welding speed, can be 48, can be 49, anything, and with whatever overlapping factor, I'll be able to determine the fracture force. So from here, I would like to conclude that a Mamdani FES model was used to predict the fracture force, which is required to break the weld strength, and it's influenced by the laser power, welding speed, and also the overlapping factor for laser welding of these similar metals. And we can also try this with similar metals. I've also tried with similar metals. It works. It also worked for my another project, which was on aluminium alloy. It worked as well. So I believe this fuzzy logic is quite useful in this kind of situation. And if we see on the beneficial part, I would say that we can use this to minimize the number of full factorial experiments, and we can also add this as one of our research materials. Like I say, we can do the research in this fuzzy and see how we can get the optimum and what is the best that we can get. And once we have the access to the lab, we can try on the values. And even though we had limits to the laboratory, and we can still do this fuzzy logic because we just have to work from our own workspace. So That is what I feel is beneficial. And during this pandemic, I have also tried with whatever data that I have earlier, and hopefully I will start to publish it soon. So that is my presentation about fuzzy logic, and I hope you have uh, gained some sharing knowledge with me presenting it to you today. So thank you for listening.
Thank you, Dr. Shamini. You managed to
Thank
explain
you.
it in a way that is easy for the layman to understand.
Thank
Dr.
you.
Shamini, I have a question for you.
Sure.
Can I know what is the software that you need to study fuzzy logic?
Oh, very good question. I did not mention it here, right? Actually, I use MATLAB.
MATLAB. Okay.
Yes. Actually, in MATLAB, they have, if normally it's installed, how to say, the default installation, they don't normally tick the fuzzy logic. So when I used it in my current lab, I told our IT tech, I said, please install everything. So then they asked me, is it all this included? I said, yes. There's a small button for you to install together with the fuzzy. So once we
All
install
right.
that, I think most of the universities, they have this MATLAB because that is quite common to have the software.
Yeah, that's
So,
right.
yeah, so having this fuzzy is actually is not additional cost anyway. I would say that.
All right. And also, we definitely need to verify the experiment. We need to verify the data through physical experiments, is it? After you have obtained the data from fuzzy logic
Okay.
studies.
It's like I'm building like a, I'm building a block, when I'm doing the 18 sets of rules, I have done my experiment. So whether my experiment is, how to say, it's valid or not, I am trying with different parameters, which is not feasible maybe because in the machine, maybe I can't set to 255, for example. But I want to inform this to another person or make up because we are doing for research. We want to commercialize. So we want to inform to the industry partners, you can use this kind of values. So for that, before we say that our model is complete, like how to say, when we build a block, we try to knock it down and see whether it's strong or not, something like that. We have to do not much, actually around 6 data is enough. From this 6 data, if you are getting this r square above 0.75, then you are consider this model is perfect, is good. So you are confident to tell it to anyone, you can use it.
Okay. So regardless what, we still have to have the physical experiments before
Yes.
we can actually work on the fuzzy logic itself.
Yes. So what I did is, when during this pandemic, whatever result that I had in my hand, which is like previously done, in 2019, 2018. So I have the output value. So I build up the model, and whenever the lab is open, they have a certain hours open, right? During the pandemic, not everyone can go and all these kind of things. I just run these 6 experiments, and I can verify that my model is complete. Then I can actually write about it.
Okay. So we cannot use fuzzy logic for at the developmental stage, right? For something that is completely new, we couldn't do that.
Yes, no.
I see.
We still need a certain data. Like, for example, if you want to say whether I'm honest or not, you have to know about me first. So same goes to that. You have to know about that output first. You have to know, okay, this output will give this. Without knowing that, you cannot predict them.
All right. Thank you, Dr. Shamini.
Thank you, Dr. Caroline.
Audience, do you have any questions for Dr. Shamini? Okay, Dr. Stephen has a question. He wants to know whether how large the data should be to be given to give a reasonable accuracy.
Okay, I would say initially we need at least 18 sets of data, because it's like a block that we're going to build. So this block needs points for every age. So we need 18 rules, but I have seen people have done with 14 rules as well. So I have used most of the time 18 rules. The reason is because the more points you have, the more stronger is your model. You can do
Alright.
it, you can do it lower, but then sometimes, for example, you build a box when you don't have enough support, the model is not so strong. So this is also similar to that. And I would like to say that this fuzzy logic, I learned it through another friend who he learned through another friend. So it is like we just pass the knowledge to each other, and there was not really a training session arranged for this. So as we play around, actually we can find a lot of things. So like what they asked just now, how much we can have. I have, like I said earlier, my friend, he had put even 14, 16, but I prefer to put 18. I feel it's more solid.
Oh, okay. All right. Thank you, Dr. Shamini.
Thank
Definitely another option for us to explore.
Yes.
All right. So I think we do not have much time for Q&A. So if anyone else has question for Dr. Shamini, you can continue to post your question on the chat box, or you may get in touch with her.
Yes, definitely. Anyone who's interested can always email me. This is my email address. Maybe I should have put it down. Okay, I'll put it here. So if anyone interested, they can always contact me. We can work together on this field, because this fuzzy logic, if after some time when we don't do it, we tend to forget, because it is like, it's setting up the rules, and if all that lah. So whoever would like to know about this fuzzy, we can talk more after the session.
Thank you so much, Dr. Shamini.
Okay, thank you. Okay, bye.
Hi, good evening, everyone. So I'm Dr. Stephen Lim, and here our second presenters will be the professor from the Department of Chemical Engineering, Faculty of Engineering from King Mongkut's University of Technology, North Bangkok, Thailand. She is Prof. Chantarapont, with her presentations Development of Medical Oxygen Generators for High Flow Oxygen Delivery with IoT for Remote Control. So a short biography about with Prof. Chan here. She received her PhD from Carnegie Mellon University, Pittsburgh, USA in 2000 under the Chemical Engineering programs. She is currently working as a professor in the Department of Chemical Engineering in King Mongkut's University of Technology, North Bangkok, which she has been serving since 2002. She was formerly the Deputy Director, Science and Technology Research Institute, Science and Technology Research Institute in KMUTNB. She has been very actively involved in the research while committed in publishing in-depth research papers. So without further ado, let's welcome Prof. Chan.
Thank you for your kind introduction, Dr. Stephen Lim. Okay, let me share my screen. Now you see my screen, right?
Yes, we can see clearly.
Okay. Hi, everyone. First, let me thank the University Tunku Abdul Rahman for organizing this exciting event and for inviting me as a guest speaker. I'm happy to share my experience during the pandemic situation in Thailand and my perspective situation in Thailand on how COVID has affected job prospects in engineering fields. The topic of my talk is the development of medical oxygen generators for high flow oxygen delivery with Internet of Things for remote control. So the outline of my talk, I divide the content into 4 topics. First is the oxygen supply in Thailand before and during the COVID-19. Second is the case study at the Erawan-3 Hospital, a field hospital in Bangkok, Thailand. And third is the background of research and development behind medical oxygen generators. And finally, the perspective for opportunities after the COVID-19. Okay, let's start with the oxygen supply in Thailand. The country has a number of large-scale oxygen plants that employ cryogenic air separation technology. The national production capacity is around 1,750 million liters per day. 1/5 to 1/3 of the oxygen product had been used for medical purposes. In practice, the quality of oxygen for medical use and other applications are indistinguishable. About the same purity, most oxygen are supplied from the oxygen plant to liquid oxygen tanks and oxygen cylinder. Very few amount of oxygen are supplied via on-site oxygen generation. Okay, for the distribution of oxygen. Before the pandemic situation for large-scale hospitals, or they need bulk supplies of liquid oxygen because bulk liquid is cost-effective. Liquid oxygen is delivered to fill in the oxygen tank located outside hospital buildings. Oxygen is drawn off as needed, passed to a pipeline, passed to a vaporizer first, and turned into gas before it is piped to individual wards of the hospitals. For small-scale hospitals, which are often located far from city, there will be private enterprise that buy bulk liquid oxygen and distribute oxygen in the form of oxygen cylinders. They will need oxygen filling station that vaporize the liquid oxygen into gas and fill the gas into cylinders. In Thailand, there are about 700 small hospitals located around the country. The small hospital, the size is categorized according to the numbers of patient beds. For the small-scale hospitals, we have 30 to 150 patient beds. During the pandemic situation, there were shortages of oxygen due to main reasons. First, there were significantly increased demands for COVID-19 patients. The COVID-19 patients were divided into 3 groups, depending on their symptoms: green, yellow, and red. The green patients require oxygen at a maximum of 5 liters per minute, while the patients in the red group would require 50 liters per minute via ventilator. And for the yellow patients, they will need oxygen depending on their conditions. It was estimated 50% of the yellow patients will require 5 liters per minute. 50% of them will require 10 liters per minute. And 20% of the yellow patients will require 20 liters per minute. The second reason for the oxygen shortage was due to the bottleneck in oxygen delivery because the patients were all around. Late patients, most of them were admitted to the large hospitals, while yellow and green patients would stay at field hospital or home isolation. This graph shows the numbers of the oxygen required during the COVID-19 situation. For Thailand, the situation was worse in July to August of this year. During that time, the oxygen demand was as high as the national production capacity. During the pandemic situation, people started to look for alternative oxygen supplies, including oxygen concentrators and oxygen generators. There were significantly increased demands for oxygen concentrators. All of them were imported, with more than 70 brands increased significantly. And the oxygen concentrators must be certified by the Ministry of Public Health before allowed for commercialization in the country. And for the oxygen generators, in contrast, oxygen generators, let me explain that they will have larger size and larger oxygen production capacity. Oxygen generators paid only small contributions during the COVID-19 because there was no local manufacturer in the country, and also it will take quite a long time to set up one system. So in the next part, I would like to talk about the case study at the Erawan 3 Hospital. Erawan 3 Hospital is located in the south of Bangkok. The place was a community sports center run by the Bangkok Metropolitan Administration. The community sports center was turned into a field hospital during the pandemic and had a capacity of around 300 patient beds and for green and yellow patients. The hospital employed more than 100 units of oxygen concentrators and also oxygen cylinders for the care of green and yellow patients. However, there was a problem when the conditions of the yellow patients turned red, which has been reported that they turn red anytime, unpredictable. So in this case, the patients then need 50 liters per minute of oxygen via ventilator. And you think with the standard oxygen cylinder contain 6 cubic meters of oxygen, so it will be gone by 2 hours. And that leads to high workloads for nurses to change the cylinders. And also, there was not enough oxygen supply. So we got contact from the hospital staff at the Erawan 3 Hospital, and the research team spent about a week for the setup of an oxygen generator. The task include site survey. In this picture, the building behind was the place that the patients stay. And the second task is the equipment assembly. And the third, we move the units to the site. And the fourth is the on-site setup. And the fifth, we test the system. And finally, we present our equipment orientation to the hospital staff. Okay, the main units of the oxygen generator system consist of air compressor, air receiver tank, air dryer, and desiccant. So through these units, the air will be compressed to high pressure and dry enough. And we said it has good quality to send to oxygen generator. So the oxygen generator will separate oxygen and nitrogen from the compressed air. And the oxygen produced will send to an oxygen receiver tank. At Erawan 3 Hospital, the concentrated oxygen was directly piped to each patient bed. Also, the system was equipped with oxygen sensor, pressure transmitter, thermocouples, as well as PLC. We also implement a direct connection from PLC to cloud. And this enables us to remote monitoring and controlling the system. These figures shows the user interface for the mobile monitoring and controlling. We can remote access, view the important parameters, and control the main equipment. For example, we can see the temperature of the dry air, pressure of oxygen purity. We can also change the operating parameters. We can control on and off of the main equipment like air compressor, air dryer, and air desiccant. So in the next part, I would like to talk about the background, research and development of the oxygen generator. The oxygen separation from air is based on the principle of gas absorption. Commercial type axiolite are nitrogen selective. So most nitrogen are absorbed on the absorbent, while oxygen is separated from air and flow through as a product. For the process design, we must consider macroscopic influence, including size of absorber, shape of absorber, gas velocity. Also, we need to consider mesoscopic influence, including nature of fixed bed, bed porosity, shape and size of particles. And we need to consider microscopic influence, including textural properties, surface chemistry, and accessibility of the molecules to the pore of the absorbent. On the basic data for design and absorption process is the absorption isotone. Absorption isotones show the absorption capacity of an absorbent at each partial pressure. So this is an example of the absorption isotones of oxygen, nitrogen, argon on various types of zeolite like 5A, 13X. For some high experienced engineers, they might be able to design an absorption process based on just isotone data. In contrast, for people with less experience, modeling and simulation would be very helpful. For example, Aspen absorption simulation that integrate momentum balance, material balance, energy balance, transport rates, equilibrium absorption data, the absorption isotones into a mathematical model would allow us to improve process understanding, to identify optimal designs and reduce the number of experiments. For the chemical engineering curriculum at King Mongkut University of Technology, North Bangkok, we offer our students the basic knowledge of gas absorption and the hands-on experience on pressure swing absorption via the chemical engineering unit operation and the unit operation laboratory. Another note is that a medical oxygen generator must be certified for the standards for the medical electrical equipment. The IEC 60601-1, the standards was published by the International Electrotechnical Commission and has become a requirement for the commercialization of electrical medical equipment in many countries. So we have worked hard to get the certification. Oxygen analyzer is another essential component of the oxygen generator. Buying oxygen analyzer would not be cost effective. So we developed our own oxygen analyzer from a commercial oxygen sensor. This enables us to online monitor the purity of oxygen product from our oxygen generator. Okay, let's move to the final part, the perspectives for opportunities from our experience. After the COVID-19 situation, after the peak, oxygen generators may be a suitable option for small-scale hospitals, especially for those located in remote areas and difficult to reach areas. Policy recommendations have been recently proposed to address the increasing trends of oxygen demand. A related recommendation is that a central bank of oxygen cylinders should be created in communities in order to ensure adequate delivery for patients to handle a pandemic situation in the future. Also, as people become more concerned about health and hygiene, there are opportunities for new products related to oxygen, such as oxygen therapy, oxygen room for elderly and patients with lung disease, oxygenate water for promoting health, and oxygen generation for ozone generation. For effective disinfection, ozone has been proven to be highly effective in killing bacteria, fungi, and molds, and in activating virus. It's fortunate that the Thai government offers funding opportunities for new product development, as well as university spin-off companies. So in conclusion, in this presentation, we showed an example of product based on chemical engineering principles integrated with digital technologies. We foresee the opportunities of oxygen generators for use in small-scale hospitals in the remote area. We also foresee the emergence of small-scale generators or large oxygen concentrators. The size has not available commercially. With around 50 liters per minute of oxygen production capacity for small hospitals in remote areas. So in such case, oxygen therapy could be delivered to each individual using high flow oxygen through nasal cannula and can decrease the rate of mortality for respiratory failure. And as people become more concerned about health and hygiene, there are opportunities for new products related to oxygen, such as oxygen room, oxygenate water, oxygen therapy, ozone generator. These can be opportunities for university spin-off companies. Finally, I would like to make acknowledgement for the research fundings, supportings, and the research team at KMUT-NB. And based on this work, the research team received an award, the Prime Minister Award for Innovation for Crisis. All right, thank you for your kind attention. I'm happy to have a discussion with you. Thank you.
Yep. Thank you, Prof. Chandrapon, again for her sharing of the experience in the development of medical oxygen generators, especially during the peak of the pandemic. I believe these issues has actually caused a lot of life being lost. So with this advancement in technology, hopefully we'll be able to tackle similar issues efficiently in the future to prevent the loss of valuable lives. Okay, so with that, I would like to open the floor for question and answer. Is there any questions from the floor to direct to Prof. Chan? So Prof. Chan, maybe I'll ask one question. So yeah, it's very interesting regarding this development of medical oxygen generators, especially it's based on the application of absorbents such as zeolite. So what I'm curious is that is there any control philosophy that has been applied to these oxygen generators? Let's say if the purity of the oxygen is fluctuating, what are the steps taken in this system to actually address this fluctuation?
You mean fluctuation in the air inlet or as our oxygen product?
Yes.
The fluctuation of oxygen quality
yes,
from our generator, right?
Yes.
We need to closely monitor the oxygen purity. Actually, real-time monitoring, and the digital technology should be embedded so that there's an alarm warning the operators as soon as possible that the purity of the oxygen drop below the expected values. But usually the oxygen purity will fluctuate in narrow range, like 2% is acceptable. This is because the temperature is an important factor controlling the efficiency of the separation of the absorption capacity of the zeolite. So 2% fluctuation is acceptable. But if the concentrations are drop below the set values, that will be strange and the system must be shut down automatically.
Oh.
Yeah, and in a hospital there should be like a backup oxygen in that case.
Yeah. Okay. Thanks, Prof. Chan, for your answers. So we have another question from Eng. So his question is regeneration required for the zeolite adsorbents after saturated with nitrogen gas? If yes, how the regeneration process is done?
That's why the process is termed the pressure swing absorption, because when one column is the zeolite is filled up with nitrogen, it got to be regenerated in the process. It is done by decrease the pressure to the ambient level due to the atmospheric pressure. And also we need to split a certain quantity of the oxygen product from another column to purge the zeolite. So the oxygen purge will have the regeneration better than only in addition to reducing the pressure.
Yeah. Okay. Thanks, Prof. Chan, for your answer. So I think we can have one last questions from Liu Kian Yu. So I'm amazed with these machines. May I know what is the estimated cost to build one of these oxygen generator machines? And how many small-scale hospitals in Thailand is currently using this oxygen generator?
Okay, the cost and the numbers, right? Okay, well, let's see. I have it in Thai baht. Let's say talk about the numbers. There's at the current there are very few hospitals in Thailand that employ this type of technology. Maybe five to 10, because the cost for the import units very expensive. It's like a cost that we built here is up to 8 million baht. I'm sorry, 30 baht equals $1. So it's quite expensive, and it makes the break-even year quite long. So in terms of price, it's not economic. It's expensive. Yeah, but we think that if the Thai people can develop our own technology, the price will reduce a lot and become accessible by the small hospitals.
Yeah. Okay. So thanks, Prof. Chan Tarapon, for the clarifications. I think if there's any further queries, I think we can contact Prof. Tarapon to answer the queries. So due to time constraints, we'll move on to our next presenters. So thanks, Prof. Chan Tarapon, again. Thank you.
Thanks a lot.
Yeah. So next, we'll invite Dr. Jasrina and Xavier for our presentations. Aiding cancer patients through design thinking, a COVID-19 case studies. So a little short biography about Dr. Jasrina. So she's a senior lecturer at School of Management and Marketing, Faculty of Business and Law of Taylor's University. She has been in the academia for the past 10 years, teaching subjects such as international business, strategic management, venture creations, and design thinking. Dr. Jashrina completed her PhD in University of Malaya in entrepreneurship development. Her research is now focused in the area of ethnic, women's, and social entrepreneurships. She has published in journals such as Journal of Southeast Asian Studies, Journal of Asia Business Studies, Journal of Social Entrepreneurships, and more. She is also a certified professional coach, design thinker, and a member at the Malaysian Institute of Management. So without further ado, let's welcome Dr. Jashrina.
Thank you, Dr. Stephen. I hope I can be heard loud and clear. So I will share my screen. And I hope that my screen can be seen.
Yep, I can see it's clear.
Okay. Yeah. Thank you. All right, good evening, everyone. I'm Jashrina, and today my topic will be on aiding cancer patients through design thinking. This is actually a COVID-19 case study that I did it with my students, and we managed to get a client which was battling with this issue on how to aid cancer patients through design thinking. So I'm from the Faculty of Business and Law and from Taylor's University, Malaysia. So just a brief introduction on how COVID has impacted businesses around the world, not just Malaysia. And of course, we see a lot of weak economic and financial results due to these changes, cutbacks, disruption in supply chain, all right, and various areas or various sectors in the employment has been affected. And the ripple effects is continued to be seen on a global scale. And until now, I believe it's not measured and the situation is yet to stabilize, okay? So how do we come out of this uncertain time and how do we recover? So one of the things that we do in design thinking is to understand what are the problems and how to solve it through design thinking. Okay, so let me just share a little bit on design thinking first. So design thinking is actually a tool to innovate and to problem solve. Okay, and what we have been doing is we have tried to help organizations, okay, during this COVID-19 pandemic, helping them to solve issues, be it small issues or larger issues. And we want to focus on the principles and practices of this method because very little is known, especially in this part of the world, on how design thinking can be used to manage humanistic and organizational challenges. Okay, so this study that was done is extraordinary because we actually managed to get a pharmaceutical company as our client. They would like to remain anonymous, therefore I am keeping it anonymous. They are part of, they are from Europe, okay? And what they wanted to do is to aid their customers, which are mainly cancer patients, through this COVID-19 pandemic. Okay, so the main two objectives of the study is to understand the experiences and challenges of the cancer patients, which are actually patients of this pharmaceutical company. And of course, we also wanted to provide solution to this pharmaceutical company, okay, which will then benefit the cancer patients, right? So maybe I will explain a little bit on design thinking. So design thinking is actually a 5-step process. Okay, it starts with empathy. It moves to define, ideate, prototype, and test. Okay, so it is not an iterative or linear process. Okay, which means that what I mean is that it's not empathy first, define, ideate, prototype, test, and that's it. So it could move from empathy to define to ideate. All right, and then you realize, okay, I'm not very sure. You go back to define. Okay, and then if you could move from define, ideate, prototype, and when you're prototyping, you're not very sure, you can go back to ideate or define or even empathy. And then you can go back to prototyping and testing. So it's not a linear process. We call it a non-linear process. Okay. And the methodology that I've used, right, for this study was actually an action research alongside a single case study. Okay, so action research basically is a research that you have a question, you want to solve a problem, right? So what we did was we actually focused on the change. So what has happened? What is the change? And we reflected on it. All right. So if you look at the on the right hand side, I have a diagram. So we actually collected our data. Okay. We had the interpretation, right? And then we looked at what are the ideas or what are the action. We took the action. All right. So this is action and reflection. We used a single case study here because it is looking at a very specific case. And we do not want to have too many cases because then we will not be focused enough. So we want to focus on this one pharmaceutical company to help them and their patients, all right, to understand the reality and to actually help this one particular pharmaceutical company. So let me talk a little bit about empathy, a little bit more about empathy and define. Empathy is very different from sympathy, right? So empathy is when you actually feel someone's pain. Sympathy could be like you see their pain, but you don't feel it with them, right? So when we collect our data, we actually empathize instead of sympathize, right? So here, of course, this is my own view, is I feel that empathy is actually the main part of the data collection itself, right? And once you can empathize well, that means while you are talking to your clients, right, you empathize very well with them, you can then define your problems. Okay, so in design thinking, we define our problems, and the question that we create will start with 3 words, which is how might we. The reason why it starts with how might we is because we want to help our clients, or in this case, the cancer patients, right? So we came up with 2 questions, right, which is how might we assist the breast cancer patients receive medication in a timely manner. So we actually focused on breast cancer patients only because that was what the pharmaceutical company wanted us to focus on, right? And the basis of this definition here is actually fear. When we collected the data, right, we empathized with their fear. So the patients were very fearful that number 1, they cannot get their medication on time. Okay, and number 2, what's going to happen if they don't get their medication on time? And also there was another fear, which is like if they were going to go and get their medication, could they contract COVID? Okay, so there was a lot of fear there. And then we have a second question, which is how might we assist the pharmaceutical company itself, obviously because they are our clients, in supplying this medication to the patients in a timely manner. All right, so this one was actually more business-like, where they were also very much focused on their revenue. When we spoke to the head of marketing, right, they were like very concerned with how much they're going to make in this COVID-19 period. So this was the empathy and define bit of the study. Now then we come to ideate. So ideate has 2 different sections in ideate. Ideate is convergent and divergent. Okay, so we start with the divergent. Okay, so divergent means you move this way, convergent means you move this way, right? So when we say divergent, what happens is we have as many ideas as possible, right? So the students here had to sit down and discuss on as many ideas as possible that they can come with, okay? And how they're going to execute these ideas as well, okay? So the students came up with a lot of ideas, okay, such as customize a special block in the hospital for this particular patient, to send medical team to volunteer with the patient, right, to send comforting emails, to start up a social media platform, to develop an app. They wanted to start a virtual sale. This is because of the revenue bit. Include benefits when purchasing breast cancer medication, organizing awareness campaign. I explain the awareness campaign later, to host a screening program and to make new partnerships. So all these, and there were more ideas actually. So once you have a divergent set of ideas, then we come to the convergent. So convergent here meaning which are the ideas that is going to be the most suitable for this particular company, right? Okay, so after much discussion and talking to the clients themselves, okay, we actually came up with a prototype of 2 ideas, okay. In fact, the first idea and the second idea are an amalgamation of 2 different ideas. So in the divergent phase, you can have like 20 ideas, and then you can take 5 ideas and merge them to however you want, right? And then we see which is the best suited idea. So we came up with in-house treatment by the medical team, right? And also the development of the application. Okay, so when you develop the app, okay, that is going to go hand in hand with the treatment by the medical team, which is to go in-house. This reason is being, there was some of their medical equipment that needed to be given by the medical team themselves or administered by the medical team themselves. So it's either the cancer patients go and get the medication, okay, or someone go to them. So at this point, because the cancer patients just did not, at that point in time, which was actually last year, nobody wanted to go get out of their house, right? So it was only a good idea for the medical team to go, and they developed an app in the process. And the second idea to increase the revenue was a virtual sale and an awareness campaign. So at that point of time, because there was so much of fear, it was like there was a loss in how things should be done. So they had a campaign to create awareness on, you know, look, we can actually get the medication to you. So we created that awareness. And in conclusion, for this study, right, the novelty of this study is actually detailed in the practical contribution of the application of design thinking in solving problems through action research. And this paper is actually using a single case study. Therefore, it does not lead to a statistical generalization. And just to let you know that for design thinking, we don't actually want to have a statistical generalization here, because every case is different. So for example, going back to empathy, right? Even if it's a same case, say for example, all of us here are going through COVID-19 situation, all of us here, or at least most of us here are academics, most of us here are battling with issues such as online teaching and learning and, you know, research. But the way we actually need to handle our problems is very different, even though all of us are in a similar situation. So for design thinking, we want to focus on what exactly is the problem, right? And how deep or how much information can we get through design thinking, right? And how then can we solve the problem? Because if we don't actually find the right problem, we don't find the right solution. Because when you find the right problem, your problem is half solved, right? So that is the concept for design thinking. And my last slide actually is, I actually would like to know if there's anyone here who would actually like a collaboration. For example, any one of you in any part of your field of work who is in a situation where you think you have a problem and you need solving, right? So then we can go through the 5 steps of design thinking and perhaps come up with a paper. So that's my email, and that's all for today from me. Thank you.
Yep. Thanks again to Dr. Jashrina. So it's really interesting to see how this design thinking methodology can actually help a lot of, I think, researchers in devising those solutions to a lot of current challenges, especially those faced by the current pandemic issue. I think this design thinking is quite an interesting methodology which a lot of us can adopt in our problems. Okay, so from now I'd like to again open the floor for question and answers. Yeah, we have a question from Liu Kian Yu. I see you raise your hands. Do you have questions to our speaker?
Hi, Jasrina.
Hi.
Yeah, it's very interesting to hear about this design thinking. I remember I read somewhere some time back when published in the American Society of Oncology, which is a prominent organization. They did talk about the use of design thinking. So I think just a few comments about your presentation. First of all, I think in the difference between sympathy and empathy, I'm from a palliative care field. And yeah, of course, my background is in a medical palliative care side. And so how we differentiate empathy and sympathy would be that empathy comes with an action, which means that the ability to recognize a form of suffering with an action to want to alleviate the suffering. So this design thinking actually got me at empathy, because empathy is a main thing for palliative care trainees like me. And we tend to want to recognize the form of suffering, we want to alleviate it. So I think that this design thinking has a lot of application from a micro to meso to macro point of view. From a case study such as yours, I would say that it's a micro point of view, whereby I felt that what could be even more important from this recognition of, let's just say, the delivery of a medication in time to the patient would be actually first and foremost to ask what the patient, how does the patient want their medication be delivered, and then from then on, the design thinking and the by a group of people can come together to try to address this. Because in actual fact, even in the medical field, I would be first and foremost, I would be quite embarrassed to admit that a lot of what we do is quite patronizing, meaning it's very paternalistic, which means that the healthcare worker is the one that is deciding most of the things for the patient based on the available evidence as well as the available technology. Whereas if we really do empathize with the patient's needs, what we have to do is first and foremost ask them actually what they want when a certain situation, we lay down for them, and when they have stated how they want it, then we start doing the start thinking about the ways, the ideas that come about to try to solve the problem. So it will be good, and it will be really, really powerful if it will be from a patient-based perspective, meaning asking them what they want, and then from then on we come up with ideas to try to solve the problem. So I feel that your design thinking has a lot of potential, because in a macro, on a macro perspective, if you incorporate it in oncology from a whole point of view, there could be processes in the care for a patient that could be implemented. It's just basically a group come together. You can ask the patient, oh, they come to hospital, what is the problems? They cannot find the parking. How do we solve the parking? How do we deliver the care to the patients in the community rather than to get them to come to the hospital? So yeah, I think I'm a bit long-winded, I'm so sorry. But I felt that this is a very interesting type of thinking process. And I think that it holds a lot of potential, a lot of potential prospects for time to come. I mean, if you want to collaborate, I can give some ideas, but I'm not sure whether I have the time to cater to contribute to your research. Thanks.
Thank you so much. Actually, I would definitely love to collaborate the field of medical, because I think that any field for that matter, I think that as what you mentioned earlier, right? You said that you wanted to ask the patients what they want. I think that a lot of times we forget, even us as a lecturer, right? Sometimes I forget to see the perspective of my students, and students forget to see the perspective of the lecturers. All of us are working from home, studying from home. Simple things like that, we just forget because we don't know how to empathize with each other. So in this particular case study, if you remember, maybe I'll just share my screen again. If you remember, I showed this slide on empathy here. Yeah, so if you see my first how might we question, I call it how might we question because that is underdefined. So in the how might we question, if you see, I've actually put a word there, fear. Reason being is because we forget that the cancer patients not only fear COVID. Everyone was fearing COVID at that particular time, but they had different kinds of fears as well. So we managed to actually capture that fear, the different kinds of fear that the patients were actually having. And then, of course, also the pharmaceutical company, of course, you know, they are a money-making company. We can't forego that part of them. They are a business, right? So they were also fearful of revenue. So in order for us to actually get to this fear point or the revenue point, right, that was the empathy bit for us to empathize and then define. And I think, yeah, I think it would work very well in oncology, in palliative, and things like that. I think I have another question, but thank you so much, Dr. Liu, for your sharing.
Yep. So thanks, Dr. Joshina. So we have another question from Dr. Quant. So thanks, Dr. Joshina, for your insight and sharing. Do you think design thinking can be used to enhance or streamline engineering projects? For example, development of a prototype or construction of a building. Will it be able to add in project management of these projects, such as to shorten schedule, maintain performance, and reduce costs?
Thank you, Dr. Kwan, for the question. Generally, right, okay, I think I forgot to inform this, but design thinking actually stemmed from the field of engineering, all right? And design thinking is absolutely new in Malaysia, even still new in Singapore and countries surrounding Malaysia, Southeast Asia. Design thinking can be used in any part. It can even be used in your personal life, to be very honest. All right. So yes, it can be used. However, you ask me this question and you say, would it be able to aid in project management such as to shorten schedule, maintain performance, and reduce costs? So I don't want to say when you're going into design thinking, you're going with a mindset. Just go with a mindset of problem solving. So don't go with the mindset of defining the problem already. Because sometimes, for example, you say shorten schedule, that is your definition of the problem. But when you actually empathize and you'll find that the problem was actually something else. So that was what you're supposed to fix, you know? So I don't like to put a name to the problem before I empathize and define the problem. So it can be used in any field. And once again, it stemmed from the field of engineering from Stanford University. They actually now have a Stanford Design School specifically for design thinking. I hope one day to go there and learn something from them. But thanks to COVID, I don't think that's going to be happening anytime soon. But yeah, and design thinking does have a lot of potential. And again, if anybody wants to collaborate, I am free and available for collaboration. Thank you.
Yeah, thanks, Joshina, for your answers. So is there any other questions from the floor? I have time for one last question. If anyone want to ask Dr. Joshina. Okay, so if there's no more questions, I think let's thanks again Dr. Joshina for his insightful talk on this design thinking. Thanks, Dr. Joshina. Thank you.
Thank you so much.
Yeah. So now we'll move on to our next speaker, who will be Dr. Lam Sudat from University Kebangsaan Malaysia, with his presentation titled Post-COVID plus AlphaFold, an exciting new era for structural biologies. So a short biography of Dr. Lam. So he's a young principal investigator at the National University of Malaysia and a visiting research fellow at University College London. He obtained his PhD degree from University College London, and his research interest is using computational tools to understand the structure and functions of proteins. He has also published numerous articles in reputable journals, such as Journal of Hazardous Materials, PLS Computational Biology, and Nucleic Acids Research. During this COVID-19 pandemic period, he has published a few COVID-19 articles, and one of them was named as Top 100 Articles of the Year by Scientific Reports. So now let's welcome Dr. Lam for his presentations.
Can you guys hear me? Yeah.
Yes, loud and clear.
Thank you so much, Stephen, for the introduction. I'll share my slide. Is it okay?
Yeah. Okay, clear.
Yeah, so basically, apart from thanking like Stephen, I want to thank the organizer as well, basically for the invitation. I feel really honored to have a chance to really talk in this conference. I like the name a lot, a conference on the resilience. So basically, over this pandemic period, lots of things that has happened. It has caused a lot of pain in the mental health and also in the economic wise, and a lot of things is not actually good. But having this some kind of conference like this shows us we can be resilient, and there's actually a lot of things that we can actually learn from this. And that's what I'm trying to do today, trying to give everything in a more like positive kind of way. But in fact, in my field, the structural biology basically is a field where we look at the protein structures, DNA structure, and RNA structures. There's actually been a lot of improvement. And thanks to this COVID, it was actually a good testing ground for a lot of methods. And the other good thing is actually the AlphaFold that I'll actually mention more in the future slide. So we can't run away from talking about what causes COVID. It's actually a virus called SARS-CoV-2. To infect the host cell, the SARS-CoV-2 breaches the protective membrane of host cell using spike protein. You can see them, they look like a spike. And then after that, the spike protein will attach to one of the receptor on host cell called ACE2. And basically because of this, it started the infection. So we'll start by looking at a few experimental structures of the SARS-CoV-2 protein. The first one obviously is looking at the spike protein. So it's actually a trimer where there's 3 of them. And what I did here is just coloring the top, the receptor binding domain here. So this darker shade part is actually the receptor binding domain. And then this is the part that bind to the ACE2 that have been mentioned in the previous slide. So when this landed et al. Published the paper, they actually compared this SARS-CoV-2 protein, spike protein versus the SARS-CoV protein that was found in 2004 that causes the SARS pandemic at that time. And what's interesting is they actually found that this SARS-CoV-2 actually binds to ACE2 at a higher affinity, and therefore that may explain to it why SARS-CoV-2 are more dangerous compared to the previous one. Another structure that I actually want to highlight, this is actually the first ever structures of SARS-CoV-2 that they deposited in the database, and it's actually a structures for main protease. And if you know it, the abbreviation is actually called AMPRO. This is the structures that basically proteins that's important in the viral replication. And if you actually look at here, there's actually a blue thingy here. This is actually called a peptide. Peptide is something like with just less than a few amino acid. And this specific amino acid is actually called N3. And in this paper, they actually shown that this peptide has the ability to stop this main protease from functioning. And after that, there's more studies actually looking at this protease. And I hope in the future, we'll see more stuff coming in that can block this protease from working and maybe used as a drug. Since then, there's more structures of SARS-CoV-2 that have been deposited. So currently, the SARS-CoV-2 proteins, almost all of them have experimental structures now. It's very, very interesting because what happened here is just over a course of 2 years. And if probably you guys don't know, solving across structures can take months and years just to get the crystals. And then after that, you need to get the tool to really get it. So if you actually look at the structures of SARS-CoV-2 that deposited in Protein Data Bank, basically this is a database that contains the structures of all the experimental structures. So there's actually 1,600 of the protein structures that's actually been found there. And historically, X-ray crystallography, basically the X-ray that you know, was the methods that used to do the structure characterization followed by NMR. But what's interesting, when we look at the structures of SARS-CoV-2, we can actually see a decrease in the structures that solve using NMR. what's happening, there's actually a rise in the cryo-EM, electron microscopy structures, where before this was actually the technique wasn't really mature at that time. But during this time, there's more stronger computational power and also methods, more understanding on the technical skill. So now you can see that these actually spearheaded the technology called cryo-EM in order to solve the structures. And the quality of the structures that solve is actually have a good kind of a considerable quality with the X-ray crystallography. So these structures are beneficial for bioinformatician to carry out further studies. So me, I'm not really someone that do all the wet lab because I'm not good with doing that. So basically, I'm actually a geek. So what I do is actually just take all the structures that you showed before and then do some kind of programming and do some kind of prediction and analysis. And I'm going to show you a bit of the analysis that people have done in order to understand this disease. One of the things that I want to highlight here is definitely, if you talk about a disease, you actually want to look for drug targets. And I'm pinpointing one of the research done by my colleague, Firdaus Raya. And what he have done basically is just to collect all the protein and drugs complexes that's available. And then once you have all of these protein drugs complexes, what you can do is actually find out what's the drug binding site of all of these drugs. And then after that, you can do a lot of comparison, and then you can actually compare and actually find, are there any drug pockets near the proteins in the COVID-19? And by doing so, Dr. Firdaus basically managed to identify about 20 proteins that initially was used to treat other disease, but now he suggests they may be used to treat COVID-19. Apart from it, you can also use this pipeline to find out off targets. If you're talking about off targets, it's more like when you have drugs, it's not binding to the specific proteins that you have. So what's the consequence of it? Meaning you have the side effect. So this is actually something that's very interesting done by Dr. Firdaus, right? Apart from it, this is something that I've done in collaboration with Professor Christina Rango, John Lees, and also Professor John Sartini. At that time, I was actually at home like you guys, and then we just have a wild thought. It's like, is it possible for us just to predict the susceptibility of the animal to get this COVID-19 infections? So how we did it, basically we just get the structures that we have mentioned before, where you have the SARS-CoV-2 spike protein and also the human ACE2, and we use this as a template, and then we model the respective spike protein and host ACE2 complexes for 200 odd vertebrate species. To cut the story short, basically we calculate the changes of the complexes for the mutation and also correlated this to COVID-19 infection data. And then what we found is our studies actually suggest the SARS-CoV-2 can infect broad ranges of mammals, but only few birds, fishes, and also reptile. So we created this plot, and then these are all the animals maybe in contact with humans, and all of this that highlight here actually are all the high risk one. So they can be seen near our house, zoo, and also the farm. So some of it, all of this, what we're showing is say that they have a potential to be infected, but we're not saying that they'll definitely catch it. So one of those that are quite interesting that have been found are actually the dog, some of the monkeys, the mink, and also and the cat, yeah. So basically, and our studies has been actually picked up by the CDC and also USDA and a lot of groups, and it's good. So people are actually doing a lot of surveillance on this kind of stuff. After this, we got contacted by Professor Jorge de la Fuente, and he's actually a flea expert, and he actually was found traces of coronavirus derived and ACE protein in the cat flea. So he contacted us to see, is it possible for this flea to really to catch the COVID-19. Basically, the idea is if a spike protein can interact with the flea ACE, then there's a chance that it will happen. So we're showing this, the complexes of the human versus the ACE2, human versus the SARS spiked protein. And then this is also this is showing for the flea. We can still see there's some interactions, happening. And what's interesting, if you actually look at the lice, there are actually more interactions happening and some for the ticks. This is actually showing it, these kind of ectoparasites such as feed and the lice, they may act like a biological or mechanical vector to help the transmission. Apart from talking about my result, I will talk about someone else as well. This is from Professor David Baker. What he did was actually use computation to design a coronavirus inhibitor. What he did was basically take the receptor binding domain of the structures that we have mentioned before. And what he did is actually design a lot of different protein peptide, and I think it's more like a peptide, and they can be bind to this, what's they call receptor binding domain. And by doing that, hoping you can actually inhibit the SARS-CoV-2 spike protein. He actually found one of the inhibitor called LCB1 that actually have a very high stability. And then he predicted the interactions and the residues that happens between the two. And he also asked someone to actually done the experimental studies, and they solved the structures. And what they have designing, the gray one versus the actual structures, they are almost identical. So this is showing how powerful David Baker's methods on designing inhibitors to really do something. And they have done some kind of like cell studies and actually found that this LCB1 has the potential, has the ability to really stop the infections of the SARS-CoV-2. Currently, this inhibitor is already going some kind of like drug development, so maybe there's something will happening from here as well. Apart from it, David Baker also developed the biosensor as well, basically using the receptor binding domain, and then you just put it near the sensor. If they detect the receptor binding domain, a luminance will happen, so it will light up. And then from what he has shown, the response to a receptor binding domain and also the spike proteins are actually quite high. So you can use these two to detect the coronavirus easily. This is just showing a few of the studies that actually done by the computational biologists, where and all of these tools basically at that time it wasn't really that successful. However, due to this pandemic period, there are lots of people actually try, and because maybe it's just that we care about these diseases a lot, there are lots of people actually perfect their method like us and also David Bakers and everything, and we managed to come up with something, and it proved to be a good testing ground for the structural biologists to really to understand this disease. This one, since I already showed the slide, this is actually showing there's actually other mutants, we call them variant of concern. So you probably heard about alpha, beta, and gamma variants. And there's one of the mutation N501Y that can be found, that's usually found in the spike protein. And initially, the N501 doesn't interact with the ACE2. And Dr. Bin Chen, what he did was basically using molecular dynamic simulation. What he did is showing that by changing this N501 to Y501, this has the ability to bind to two of the residues from the ACE2 side. And because of that, it may explain the stronger and the higher effect binding to the ACE2, and therefore a higher infectivity with all of these variants of concern. Apart from talking about COVID, another thing that hit us was actually something in July. This is actually due to Google's DeepMind. Basically, they have developed a method called AlphaFold. This is actually a method that uses AI that can predict the 3D structures of the proteins by using just the amino acid sequence. So they have participated in one of the competition called CASP, Critical Assessment of Structural Prediction. And in the last round, basically the one in 2022, this AlphaFold was actually, perform the best, and their accuracy can go up until 80%. Probably some of you are not familiar with this. If you can get an accuracy up to 80%, this is already having the, the power as experimental structure validation methods like an X-ray. So that's why it's very good news. Maybe some of you still can't see it. So basically the green one is actually the experimental structures. And the blue one is actually the prediction by the AlphaFold. So you can see that by putting two of the structures together, you can see that almost they are identical. What's the difference is just basically happening at the loop region, and those kind of places, usually they are flexible. So it's not crazy to see there's something happen there. And they also in the collaboration with Amble EPI, they actually model 21 key organisms in the world. Apart from human, they have modeled the rice, Arabidopsis, E. coli, and a lot of organisms. And they actually put the data, all the data into website below. Apart from modeling the monomers, they are trying to look at protein complexes as well. So by this, we are looking at dimer, tetramer, heptamer, decamer. And according to AlphaFold, their accuracy is actually quite high as well, reaching about 65%. And then these are some of the examples they have modeled. They can predict a heteromer easily, and also they can do quite well with protein peptide complexes as well. So probably some of you will have questions. So what's the impact? So if you have all of these two, what can you do? One of it was actually another work that I'm currently doing. So we were talking about our receptor binding domain a lot. There's actually another domain called N-terminal domains that are near this SARS-CoV-2 of the spike protein. So we decided to focus on this entity because this entity mediates the interactions with surface glycan, such as gliacic acid, and promoting one of process called virus surfing. Virus surfing basically is a process where the virus will go through a process of surfing around the human host cell, and then finding the best place and slowly moving towards the binding to the H2. So that's a process before the actual binding. And if we have went back and really look at what are the possible binding regions for this sialic acid, and then we actually found 3 pockets. And once we have it, we actually want to see, is it possible for us to really look at the structures from other coronavirus so that we can see, are there any conservation between the structures? Initially, we tried to use other methods to really model it, but the quality wasn't really that good. Luckily, AlphaFold was there, and we managed to model 20 odd structures. So after we have them, we structurally superpose them together. And by doing this, you can actually look at the conservation of the pockets. You can see that for pocket 1, they're actually very conserved up until 84 out of 100. Pocket 2 and 3, they're a bit on the lower side. Apart from that, we identify another interesting pockets called pocket 4, where the structural conservation actually go up to 94. So we're suggesting maybe some people actually can target these pockets in this spike protein, and maybe a drugs can be done. And what's cool about it, because they are conserved around this coronavirus, and maybe they are going to hit a lot of coronavirus. This manuscript are currently in preparation, so if you're interested to know about it, it will be out and be published in the bioRxiv quite soon. Apart from it, we mentioned the AlphaFold actually managed to model a lot of the human proteins. So by using that, maybe you guys can't see it. Previously, the coverage of the human proteins is about just 40%. With AlphaFold, it actually increased up until 70%. And another thing I actually want to pinpoint here, before that, it was very hard to model a certain type of protein, and the protein is actually called membrane protein. And you can see that the accuracy before, the percentage of like coverage before was actually lower than 30%. And now we can actually see a twofold coverage of this with the help of AlphaFold. We are also in the process of, apart from looking at human, so me and Professor Christina Rango, we're actually looking at all the proteins that's available as well, and to look at the coverage of other proteins. And we actually found that this is what we have done with AlphaFold. A lot of them actually increase the structural coverage. And what's interesting, if you actually look at the Arabidopsis, basically that's the model organism for the plant, you can see that almost all of the proteins actually have the structures now with the help of AlphaFold. This is actually a very good news. The same for the fusion yeast that's been used to study a lot of stuff. Leishmania is, if not mistaken, is another pathogen. Yeah, if not mistaken. And the manuscript also also are currently in preparation. Apart from it, AlphaFold can be used to aid experimental structure determination. This is more on the structural side. So when you have solve and create IOEM, you usually have a density map, meaning you have a map with just all the gray cloud, electron density cloud kind of stuff. And what AlphaFold can do is once they have modeled the structures, you can just use the model and feed into this electron density cloud. And they have shown that they managed to feed into the cloud that will solve experimentally nearly perfectly. They can be done to phase X-ray diffraction data as well. Can I check like how much time do I still have? Or still have a lot of time? Yeah, I just checked. I still have time, I guess. So basically, apart from it, there's another group called Alcott group that basically explain the possibility of alpha models to predict the ligand binding site. And there's also another studies that look at predicting the protein DNA binding site. And other implication, you can use this AlphaFold to really understand the complex biological network in organisms. So in our body, there are actually a lot of proteins, and currently there's about 20K protein, and all of them actually are interacting between all of them. So having, rather than just the information whether they interact, but with AlphaFold, with the AlphaFold multimodal, you actually can model the complexes. By doing so, you can really understand how the two proteins actually interact between each other. And this can be done apart from understanding the organism, you can understand the host pathogen interactions as well. And definitely, but not least, I will just show that during David Baker's part, where you can use all the structures that have been solved to really design the drugs for disease intervention. So last but not least, this is actually the slide that I want to thank some of my collaborators, especially Professor Christina Orango. He was my mentor for my PhD, and currently we're still actively collaborating for the last 3 years now. The same to John Lee. Previously, he was actually a postdoc, but now he's actually a group leader. Professor Joan Santini, someone that's very enthusiastic about those stuff. He teach me a lot of stuff outside of Skyeng as well. And also Professor Jorge Del Fuente, and also my funders, UKM, and also the Ministry of Higher Education, and definitely thank the Google DeepMind for developing the AlphaFold. And just to sum up everything, so far what I see here is actually been a very good era during this pandemic period. There are lots of news, experimental structurally characterized tools that have been developed and perfected. There's also a lot of computational tools that can be helped and have been perfected and been applied to COVID-19. And with the help of AlphaFold, this is even a bigger improvement to the structural biology world. So basically, to end with a note, COVID-19 actually caused a lot of us to suffer. However, from the view of the structural biology, this has actually been a new exciting era for us. Now, we don't need to worry about modeling proteins. The proteins are there. What we can do now is actually try to understand how the structures and more understanding the function of the protein. And by doing so, we can maybe even define a drug or manipulate the protein. So basically, it's like what you have said before. The world is your oyster in the structural biology. I am ready to take the questions, so if you guys have any.
Thank you to Dr. Lam again for providing with us such an insightful knowledge on the structural biology. So personally, I also believe that this field or information actually will be the key for us to discover more efficient treatments for COVID-19 in the futures. So now I'd like to remind the audience, you guys can pause if you have any questions to our speaker, please pause in the chat box and I'll read out for you. And now we have our first questions from Dr. Kevin. So thanks so long for your interesting sharing. Do you think the animal, especially stray dogs and cats, should also be given vaccinations to reduce the COVID infections among the humans?
Oh yeah, this is typical questions I'll get when I talk about my animal studies. So basically, the animal can catch it. And so far, there's some experimental studies that actually done on the cats and the dogs. So basically what they can get is just basically some kind of mild symptom. They won't get like us human, they will have like the pneumonia and stuff like that. Basically what they catch is some kind of flu. And so far there hasn't been what's it called, the spread from the cats to the human or the dogs to humans. So, and the other thing is probably because what's really happening and what happening human is, we are living in a place that we are interact with each other and everything. And the cats and the dogs and cats usually they just stay in their home and everything. And for the dogs and cats, I believe they are okay. Yeah, but that's what I can say. That's what I can say. I don't think the vaccination should be needed to actually give them, because we human even haven't finished the vaccination here in Malaysia as well. Yeah, so if there's some extra, why not give it to them? But at the moment, not to worry about that. Yeah, that's what I'll say.
Thanks for the lumps. So is there any other questions for Dr. Lumps? I have one question. So it's particularly on my mind for quite some time. So especially on this structural biology, so I wonder if whether the analysis from this type of research, is it possible to let us know the origin of this COVID-19 virus? Like, where does it really come from? Whether it's from human or from animals? Can you give some insight on that? Yeah.
So basically, if just gonna look at all the sequences of all the coronavirus. So currently, if you take all the coronavirus that's available at the moment and you just I would say basically organize them and put them into multiple sequence alignment and build a phylogenetic tree. Currently, the closest coronavirus that's found to is actually a rat G13. That's actually from the bat called a rat G13, yeah, that's what we can say. It may originate from that particular bat. However, whether is it man-made or not, I've read some paper saying that it's actually not man-made. But from the standpoint from human side, I don't think anyone will actually want to man-make this kind of virus and causing all the problems as well and everything. And there's also, I did a paper recently talking about this, and they actually just keep pointing back to the bat, and no one is actually talking about the into being man-made. Yeah, that's what I can say. From the biology world, I don't think it's man-made. Yeah, no. Bioinformatic world. Yeah, that's what I say.
Yep. Yeah, thanks a lot, Dr. Lam, for your clarifications. Yeah. So is there any other questions? We have time for one last question from the floor. Okay. So, okay, if there's no more questions, I think let's thanks again to Dr. Lam for providing us with such insightful information, especially on structural biology. Thanks, Dr. Lam. Thank you.
Thank you.
Okay. So now let's move on to our next presenters, who is also from University Kebangsaan Malaysia, with her presentation titled Research in Tropical Diseases, What Can We Learn from the Pandemic? So our next speaker, Dr. Sylvia Cheng, is currently serving as a senior lecturer at the Department of Biological Sciences and Biotechnology, Faculty of Science and Technology, University Kebangsaan Malaysia. She graduated with a Bachelor of Science in Microbiology in 2006. And a Doctor of Philosophy in Biochemistry in 2011 from University Kebangsaan, Malaysia. Her recent research areas involve study of host pathogens interactions and bacterial pathogenicity in melioidosis, design and evaluations of peptides for diagnosis and sustainable processes such as bioleaching of economic minerals using bacteria. So without further ado, let's welcome Dr. Sylvia.
All right, thank you, Dr. Stephen, for the kind introduction. Can you hear me?
Yes, loud and clear.
All right, let me just share my slide. All right, can you see my slide?
Yes, I can see it.
Okay, good evening, everyone. I'm Sylvia from Faculty of Science and Technology from University Kebangsaan, Malaysia. Today, I'll be sharing quite a general topic on research in tropical diseases. What can we learn from this pandemic? Right? So first of all, what are tropical diseases? Tropical diseases are diseases that are indigenous to tropical or subtropical region. For example, like malaria, cholera, and also dengue. This disease has been known since ancient time, and it has gained significant attention in the late 20th century and early 21st century. Many of these tropical diseases have been controlled in more developed countries through improved awareness and also advancement in prevention and treatment. However, some of these tropical diseases still remain as major sources of mortality and morbidity in poorer countries. And these diseases are considered as the neglected tropical diseases. Some of the challenges that remain with these diseases are, for example, socio-economic problem, limited international visibility, poor health access, and also lack of awareness, whether it's among the health personnel or also in general public. This is just a view of the burden of neglected tropical disease around the world. As you can see, most of it are centered in the region of Asia, all right, and the tropical region and subtropical region. Okay. So one of the tropical disease that I would like to highlight today is melioidosis. This is also one of the core research work that I've been doing for the past more than 10 years. So what are melioidosis? Melioidosis is an infectious disease caused by the highly pathogenic bacterium Mucorales pseudomyelitis. This disease is associated with considerable human mortality and morbidity, especially in the tropics, and is known to be endemic in 48 countries around the tropics and including nations in East and South Asia, the Middle East, Africa, Latin America, the Caribbean, and also the Pacific. In most of these countries, melioidosis is severely underreported and is possibly endemic in another 34 countries that have no confirmed cases. In a 2016 modeling study done by Limatro-Rotsakul, it was estimated that 165,000 human cases of melioidosis are diagnosed per year globally, of which 89,000 are fatal. This predicted mortality of melioidosis is comparable to measles and are even higher than leptospirosis and dengue infection. Diseases that are considered to be high priority by many international health organizations. And although the number of mortality caused by melioidosis is high, this disease is not classified as neglected tropical disease by WHO. In Malaysia, melioidosis is not a notifiable disease, and the true incidence of melioidosis is unknown, although more than 1,000 cases has been reported throughout the country. This is a summary of what are the clinical manifestations of melioidosis. It is a broad range of manifestation. It can start from asymptomatic to acute septicemia, pneumonia, and even dissemination of the bacteria to all the major organs of the body, such as spleen, prostate, liver, and also kidney. Right? So what are the major challenges of melioidosis? There are three major challenges of melioidosis. The first one will be underreporting and underdiagnosis of melioidosis. Both underreporting and underdiagnosis of melioidosis is not surprising, as most cases occur in resource-poor countries with large rural population and lack access to microbiological laboratory diagnosis. The diagnosis of melioidosis is challenging even for an endemic country like Malaysia. Why? Because due to the absence of pathognomonic clinical presentation and lack of awareness of the disease among health and laboratory personnel, thus leading to misdiagnosis, especially in rural areas. Whereas in non-endemic areas, culture of B. pseudomyelitis is discarded as contaminants. For the treatment of melioidosis, it also posed as a limitation. The current treatment for melioidosis involve long-term intravenous and oral antibiotic courses. However, the emergence of resistance in B. pseudomyeli during therapy has been reported with all the therapeutic options. At the moment, there is no melioidosis vaccine available for human use. Although some vaccine candidates has been shown to provide partial protection, but very few has been tested in human. And the third challenges of melioidosis will be poor disease management. Approximately about 40 to 60% of patients diagnosed with melioidosis will develop bacteremia upon admission, while septic shock occurs in about 20% of all cases. Therefore, early diagnosis and the start of antimicrobial therapy specific to the bacteria are very crucial for a proper management of the disease. In areas where resources for rapid diagnosis, antibiotic therapy, and care facility for managing severe sepsis are available, the mortality rate from melioidosis is about 10%. However, in many endemic regions where these resources are absent or limited, the mortality rate can go as high as 40%. So the recent pandemics has affected us in many ways, and despite the many challenges that it brought, there are many lessons that we can learn from it. So what can we learn from the recent pandemic and how do we apply it in the tropical disease research? There are three aspects of what we can really learn from the pandemic, namely infrastructure, management, and detection and treatment. In terms of infrastructure, we have seen the importance of sufficient healthcare infrastructure in the face of pandemic. More funds needed to be channeled into healthcare infrastructure such as hospital and related facility and equipment. The entire healthcare ecosystem needs to be ready to face the next pandemic of similar or larger scale. At the same time, the same can be done for research funding to support and fully utilize the infrastructure. We have seen that there is an increased allocation of funds into pandemic-related research, and researchers can fully utilize this to their advantage. Whereas in terms of disease management, we have seen how big data can be used for streamlined pandemic curbing efforts. We have seen international exchange of data between countries where data is curated and able to be disseminated into public access. We have also seen close cooperation between countries in terms of surveillance and reporting on daily incidences, and immediate action could be taken based on those data. Authorities around the world have done well in creating awareness among the public by using mass and social media, and this has helped in controlling the spread of the disease. In detection and treatment, we have seen the development of rapid and accurate detection kit that has been developed using enhanced lattice advancement. We have also seen fast development of vaccine and how vaccination efforts have been expedited in the face of COVID. This stem out of necessity to treat the disease that has plagued us since late 2019. So based on the lesson that we learned from this pandemic, I will apply it and focus it on three core areas of melioidosis, namely diagnosis, treatment, and disease management. So for the first core area will be diagnosis of melioidosis. Current diagnosis of melioidosis rely on the isolation and identification of the bacteria from clinical specimen. This method is time-consuming, laborious, and has demonstrated to be low sensitive. Moreover, as serological tests to detect the presence of antibodies against B. pseudomyeli are difficult to interpret due to poorly characterized antigen and lack of standardization or vigorous evaluation. One of the serological techniques that has been widely used is the indirect hemagglutinin assay, or IHA. Although it has been used commonly throughout the world, IHA usually has high background seropositivity rates in the healthy population in endemic area, and this reduces its specificity. Misdiagnosis by a physician coupled with lack of adequate diagnostic laboratories in rural setting, where most of these cases are expected, also contributed to the problem of underdiagnosis. So how do we improve from here? Rapid and accurate diagnosis is the key to proper management of melioidosis. One improvement that can be undertaken is to develop a non-culture-based detection method. The use of peptide sensor is suggested here, owing to its flexibility, fast and easy accessibility to target circulating antibodies. Peptides are also easily incorporated into portable diagnostic tool that would facilitate reliable diagnosis of the disease in rural areas of endemic countries where the fatality rates are high. This will allow better management of the disease while keeping the diagnosis simple and at a lower cost. Subsequently, this can potentially lead to improvement in serodiagnosis of melioidosis in the urban clinical setting. Moreover, priority should also be given in the establishment of basic clinical microbiology laboratories in tropical endemic areas to enable early diagnosis and treatment. Starting with medical students, a differential diagnosis of melioidosis should be entertained, investigated, and discussed at all pertinent clinical scenarios. Continuing medical education on melioidosis is a useful exercise in all hospitals to increase awareness among doctors. Protocol for diagnosis and management need to be in place also for urban and for rural hospital or clinic setting where diagnosis facility may be unavailable. The second core area for this is it will be the treatment of melioidosis. The resistancy of Burkholderia pseudomyelin to many antibiotics has limited the option used in treating melioidosis. And although several new antimicrobial has been tested in vitro and in animal models, but none can yet replace ceftazidime and meropenem. These antibiotics are used as the current treatment for melioidosis, which involve long-term intravenous and oral antibiotic regimen. However, the emergence of resistance in B. pseudomyelin during therapy has been documented with all the therapeutic options, pushing the need to find alternative treatments. One of the strategies to counter the current limitation in melioidosis treatment is through drug repurposing. Several recent work has demonstrated the possibility of repurposing non-drugs as potential treatment of melioidosis, such as aminocoumarins, an antibiotic, and also aranofin, a drug used to treat rheumatoid arthritis. These approved drugs were shown to be able to treat melioidosis in animal models, demonstrating the potential of alternative therapies for melioidosis. As for the development of vaccine for melioidosis, it has always been hindered by the complex pathogenicity and also strain heterogeneity of the bacteria. And although tremendous effort have been carried out over the last decade, many of these antigens used as vaccine candidate only confer partial protection when used as individual subunit vaccine. Fortunately, the emergence of a number of multi-component platforms had demonstrated high effectiveness in melioidosis animal model. These include the use of glycoconjugates, multivalent subunit preparation, outer membrane vehicles, and others which could offer a promising new candidate vaccine for melioidosis. And the last core area of melioidosis that I would like to talk about will be on disease management. Even though melioidosis has high mortality and is potentially preventable and treatable, it is not included in most lists of neglected tropical diseases, including the WHO list. Thus, effort by the international research community are needed to raise awareness of this disease within WHO, regional and local health agency, as well as in general public. Periodic and continuous health promotion, education, and training should also be given to health personnel. And in countries like Malaysia, melioidosis should be listed as a notifiable disease and reporting of cases should be made mandatory. Mandatory reporting allows for the collection of incident and mortality statistics, assessing disease trend, and help in tracking disease outbreak. Initiating a melioidosis registry will be another powerful tool to track the disease, to assess treatment and outcomes, and to follow up with patients. In developing countries, melioidosis is most common in rural areas, who often have limited access to even simple diagnostic. Furthermore, even if clinical microbiology labs are available, they might be underused owing to its cost or lack of trained staff. Therefore, establishment of basic healthcare and laboratory facility should be a priority for improving melioidosis case as settlement in this area. In terms of resources, more research funding should be provided for melioidosis researchers worldwide. As in the case of COVID-19, the availability of numerous funds has spearheaded the rapid development of both vaccine and detection kit, which in turn help in global control and monitoring of the pandemic. By recognizing melioidosis as a neglected tropical disease, this could help in raising more funds, focusing on research, surveillance, and also treatment. Moreover, to reduce acute melioidosis mortality, the availability and affordability of treatment need to be improved. In low-income and middle-income countries, the antibiotic used for treatment of melioidosis are often expensive, have limited availability, or they are excluded from the country's universal health coverage, and patients frequently cannot afford to pay the drugs themselves. Therefore, there is an urgent need on studies on how resources should be allocated and used to aid these countries in terms of getting sufficient treatments and help and infrastructure to treat melioidosis. So these are the list of the projects that has been conducted in the Department of Biological Sciences and Biotechnology, where I'm attached to. These are part of the work that me and my team, headed by Prof. Sheila Nathan, the research that we have been doing for the past 10 to 15 years on trying to close the gap on either knowledge or the understanding of melioidosis and Burkholderia pseudomallei itself, right? Our team has successfully published and collaborated with several universities around the world. And our work has focused a lot on the study of pathogenicity of the bacteria itself, and also the development of marker for detection of the bacteria and diagnosis of disease. And there are a few works that are currently ongoing that involve the use of bioinformatic analysis to identify and to design peptides for the use for serodiagnosis of melioidosis, right? So as a conclusion, melioidosis is an infectious disease associated with significant human mortalities and morbidity in the tropics, and is being increasingly reported in the other regions of the world. And there is an urgent need to prompt regulating bodies to recognize melioidosis as a neglected tropical disease. And interdisciplinary effort is very much needed to address the spread of this disease and also to establish effective melioidosis intervention. Right. Thank you very much for your attention, and I'm open for any question.
Thank you, Dr. Sylvia, on her sharing of information pertaining to the melioidosis disease, which I think shares quite a lot of similarities to the current COVID-19 pandemic that we have now currently. So I would like now to open the floor to the Q&A sessions. And I think we have a first question from Dr. Chong-Woon Chan. So it seems during the pandemic, collaborations globally for medical R&D has sped up the response to develop effective tools to combat COVID-19. For NTD, is there such collaborations or network exist in Malaysia or in the region?
Right, thank you, Dr. Chan, for the very good question. For NTD, if I focus on melioidosis, yes, there is a network for melioidosis in Malaysia that has been established in the year 2015. This network involves the collaboration of various local government and also private university across Malaysia, and also a few hospital, right? From this network, we share ideas and also share data among each other. Then it has kind of helped in increasing the awareness of melioidosis in Malaysia, right? But so far, at the moment, more effort are still needed. All right, we are not as extensive as the one that we've seen for COVID-19, but we are on our way to involve more participation, especially from the government side, from policymaker, from practitioner, and also health personnel. But definitely, effort has been still ongoing on that.
Thanks for the answers, Dr. Sylvia. So yeah, we have our second question from Dr. Siu Hong. So thank you very much, Dr. Sylvia, for the presentation. Since melioidosis is a dangerous disease, is there any reason why it is not listed in Malaysia?
Thank you, Dr. Shid, for the question. Melioidosis has been identified in Malaysia as early as the 1950s, all right? But because due to the underdiagnosis and also underreporting of melioidosis in Malaysia, due to the lack of awareness, and they don't make it as a it was not emphasized during the course of study for medical doctors, and therefore we have underdiagnosis and underreporting of this case. So it doesn't attract the attention of the government to make it as a notifiable disease in Malaysia, right? Because they do not see the need for it due to all these factors that I mentioned before, right? But therefore, with the establishment of the melioidosis network Malaysia, we have tried to make this disease as a notifiable disease in Malaysia through the help from various hospital and also doctors that are involved, right? So the effort is still ongoing. We are still trying to make it being listed as one of the notifiable disease in Malaysia, and also to make it as a neglected tropical disease in the WHO list of these NTDs.
Yep, thanks, Sylvia, for your answers. So we have another question from Dr. Chong-Woon Chan as well. Again, so as a researcher for such neglected diseases, so how do you influence policymakers to advocate more fundings and focus of research in this area?
Right. Thank you, Dr. Chong. So I think as a researcher, what we can do is we can create awareness. We have to make our work out there. We have to make our work more public so it can be assessed by the general public. and we through various conferences, whether it's local or international platform. I think we also need to go down to the ground to meet with the people, to talk with the people, to talk with all these policy makers on the importance, and also how dangerous is this disease if it's not being controlled properly. Right, so I think the most important as a researcher, how do we influence and advocate this, is we need to make this disease as publicly as possible, to create that awareness in public. That is what is currently lacking in Malaysia. The awareness of the disease is still not there. Yeah, because it's kind of like a disease only a certain group of people will know. The public do not really know yet, even they never heard of the name of the disease before.
Yes, thanks, Dr. Silva. So particularly thinking it's very important to actually raise the awareness, as what Dr. Silva had just said. So
Yes.
we have another question from Dr. Ho Chun Long from SASTEC. So, hi, Prof. Silva, what approaches could be taken to foster further international collaborations? Could you share any ideas on this subject matter?
All right, thank you, Prof. Ho, for the question. I think what could be done to foster further international collaboration is in Thailand especially. All right, I will use Thailand as an example. Thailand has been very open for international collaboration, especially in myelofibrosis, where they actually has a tropical disease center in Mahidol University. And this tropical disease center has been established in collaboration between Mahidol University and also university from the UK, including the Wellcome Trust Center. So I think for a country need to be open for this collaboration and to bring ourselves out there, in a conference or through our publication. And there is a lot of international fundings that are available out there, such as from the Wellcome Trust Center, even WHO themselves have grants, big grants that can be applied, especially in these diseases. And what we need is just to be open up to apply for it and to have a collaboration with professors and researchers from overseas. And most of the time they are very open to it. And in example, with our own research team as well, we have several collaboration, for example, with the University of Stanford from the United States, and also from Sheffield University, where the collaboration has been ongoing for the past 15 years. And through that collaboration, we are able to secure quite a number of research fund to develop the myelofibrosis laboratory in UKM now. All right, so I hope I answer your question, Prof. Ho.
Yep, thanks, Dr. Silva, for your answers. Yep. Okay, so just last questions. Is there any other questions from the floor to our speaker, Dr. Sylvia? If no, then I think, yep. Thanks again, Dr. Silva, for providing with us such a elaborative information about this myelofibrosis disease. Thank you again.
Thank you so much, Dr. Steven. Thank you, everyone.
Yep. Okay, thanks. Okay, so ladies and gentlemen, so we're now at the last, but certainly not least, presentations of our sessions today, which will be presented by Dr. Chen Jun with the title of COVID-19, a perspective of microbiome research. So a short biography about Dr. Chen Jun. He's currently a postdoc in the Department of Biomedical Engineering at Southern University of Science and Technology. His present research focuses on the human microbiome, focusing on bone and gastrointestinal related microbiome. In 2020, he received a PhD in biochemical engineering from Nanjing University of Science and Technology, China, under the supervision of Professor Shuling Yang, specializing in microbial biochemistry and molecular genetics. During his PhD, he engineered microbes to produce secondary metabolites, including elucidating the catalytic mechanisms of core enzymes involved in the biochemical pathway. These research works were published in international journals, including the International Journals of Biological Sciences, Carbohydrate Research, Biochemical Society Transactions, and Frontiers Molecular Biosciences. So without further ado, let's welcome Dr. Chen Jun.
Hello, everyone. Can you hear me?
Yes, we can hear you.
Oh, okay, thanks. Let me share my screen. Can you see my screen?
We haven't seen your slide yet.
Wait a moment.
Yeah, sure.
Okay.
Yep, we can see your screen now.
Okay, thank you, everyone. Hello, my name is Dr. Chen Jun. I'm from the Department of Biomedical Engineering, Southern University of Science and Technology. I'm from China. My topic today I'm going to share is COVID-19 perspective of microbiome research. The first I want to talk about is COVID-19, and then next is human microbiome, and the third is COVID-19 patients microbiome. As we know, COVID-19 results from the infection of the coronavirus SARS-CoV-2. The replication of SARS-CoV-2 in the host cells are came here on the left picture. We can see then the first the coronavirus will enter the host cells with the help of the ACE2 receptor. After entering the cells, the virus genes will be expressed, and the expressed proteins from the virus genome will be assembled to the new virus. After assembly, the new virus are released, and the second round of infection begins. And the clinical manifestation of COVID-19 can be seen on the right picture. We can see, and we know that the SARS-CoV-2 main catalysts are lungs. So the infection can result in some severe symptoms. For example, pulmonary edema, dyspnea, acute respiratory distress, and acute lung And furthermore, the infections will lead to further reactions. For example, we can say that the cytokine storm, the cytokine storm will further lead to other tissue damages, for example, liver, kidney, and other tissues. So the COVID-19 has caused a lot of damage to our world. The second I want to talk about is the human microbiome. Microbiome refers to the genomes of all the microorganisms in a specific location or a niche. The human microbiome refers to all the microorganisms on or in our body. For we know that there are many microorganisms on our skin, or in our gastrointestinal tract, or in our pulmonary tract, and then our health is associated with these microorganisms. For example, these microbes can help us to digest food, influence mental health, promote skin health, and so on. We can, for example, the microorganism in our mouth can assist our digestion and ward off pathogens. In our lungs, we know that our lungs are inherently have many microorganisms, including bacteria and virus. And then this microorganism in our lungs can help us to lubricate our pulmonary tissues. And the there are many other microorganisms in our stomach. We can say that although the in our digestion of our food in our stomach, the pH is very slow, but there are still many microorganisms in our stomach. It can the bacteria in our stomach can prevent some gastric complications, and some bacteria in our colon, it can help us to digest some complex carbohydrate. And another important location is our skin. Our skin are exposed to the exterior environment, so there are many microorganisms on our skin. Microbes can also have some important roles for our health. For example, it can fortify our immune system. Okay, the third is I want to talk about is COVID-19 patients' microbiome. COVID-19 results from the infection of the virus, and there's a SARS-CoV-2 virus. Many colonize our lungs and our respiratory tract. So researchers mainly focus on the microorganisms in our respiratory tract, including upper and lower respiratory tract. And they get a sample from nasopharyngeal or sputum, or the third samples from the upper respiratory tract. And they get, for some patients, the research gets some from the lower respiratory tract, from the bronchoalveolar flash, lavage fluid, or lung tissues. And noteworthy, some research also investigate the intestinal tract microbiome, because the intestinal tract has the most abundant microorganism in our body, much higher than other body parts, for example, including our skins or pulmonary tissues or respiratory tract. So, and more importantly, the microorganisms in our intestinal tract have some very important roles. So many investigators also focus on the effect of the intestinal tract microbiome on our health, and they want to know whether this microorganism in our intestinal tract can have some effect on the COVID-19 infection. So they get this microorganism from the two parts. Okay, sorry. Okay, the first I want to share is, sorry, the upper respiratory tract microbiome. Some study shows that there's the microorganism diversity for the COVID-19 patients and the healthy volunteers. The results show that there is no difference between the patients and the volunteers for the nasopharyngeal swabs. But for the sputum samples, we can see that the patients have a lower diversity, but until now we just know there's a phenomenon, but we don't know yet the reason why there's a lower diversity for the patient. Further study shows that the patients of COVID-19 have enriched the opportunistic pathogen abundance. Of course, there are other pathogens for the COVID-19 patients, but the most abundant is the opportunistic pathogens for the patients. We can see that there are Candida, ambicans, and so on. But the roles of the increased opportunistic pathogens are not known yet. Maybe this is very difficult for us to investigate the real reason, and it may need many more work to explain this. Okay, the second is the lower respiratory tract microbiome. We can see that there, for the level of general, from the 20 patients, we can see that no matter the bacteria general in us or the fungal general in us, there is no significantly difference for the patients. So, and the reason and the mechanism of the difference, the little difference between them are also not known yet. Maybe it needs more work to elucidate the pathogenicity or the mechanism for the COVID-19 diseases, because this is a very complex process. Okay, the third is the intestinal tract microbiome. I want to say here is that some COVID-19 patients had some increased numbers of opportunistic pathogens, including Clostridium heteroides, actinomyces, and bacterial whites. But the metabolism of the increased opportunistic pathogens are not clear. How they infect or affect our immune system or the COVID or the coronavirus, we don't know yet. And then the second I want to say is the severity of COVID-19. It is associated with the intestinal microbiome. As I said earlier, our intestinal microbiome is very important for our health. It can influence many parts of our body, even including our mental health. So a study shows that the Firmicutes is associated with the severity of this SARS-CoV-2 infection, but the reason, the underlying mechanism is not clear yet. The microbiome is a very complex system, so we need many work to explain or investigate the reasons and the mechanisms. Okay, this is some references. At last, I want to say thanks to the organizers and the audiences and my supervisor, Professor Ho Chun Long, and our team. Thank you very much.
Thank you again to Dr. Chen for sharing with us the insightful knowledge, especially on how human microbiome and its connections to the COVID-19 pandemic. I'm sure it's a very useful information to a lot of us. So here, I'd like to again open the floor for Q&A. If any questions, please do post in the chat so that I can read out to the speakers for you all. Is there any questions from the floor? Yeah, Dr. Chenju, maybe I start with one question. So yeah, it's actually really interesting on how the human microbiome project works, and especially about its connections to the COVID-19 pandemic. And you have said that basically the COVID-19 patients basically have an increased the pathogenic activities in their intestinal microbiome, right?
Yes.
Yeah. So do you think how exactly does the COVID-19 virus actually affect those intestinal microbiome in humans? Can you elaborate more details on that?
Okay, thank you. First, I want to say that the virus and the intestinal microbiome, I think they have some interactions from the virus have some effects on the microbiome, intestinal microbiome, and also vice versa. The intestinal microbiome also have some effects on the SARS and this virus. although the lungs and our intestinal tract are very far, so maybe they have some very indirect interactions. Maybe, for example, some microorganism in our intestinal can secrete some metabolites to stimulate our immune system to increase or decrease, and our immune system can control or infect the virus infection. And likewise, the virus infection can also have some effects on our immune system, and the immune system are correlated with our intestinal microbiome. If we have some increased immune system or decreased or compromised immune system, our intestinal microbiome will change. I think they have some have some interactions. Okay, thank you.
Yeah, thanks, Junjun, for the explanations. Yeah, I think it's very interesting. So perhaps with further development, I think this human microbiome, especially in the intestinal traits, those that can maybe form a possible future cure, the cure for our COVID-19 virus, right? Is it possible, or like what kind of development has occurring in this direction so far? Can you share some of the insights?
You mean
Yeah.
In my opinion, I think it's possible for the human microbiome and the COVID-19 infection. But the mechanism or the work, the current work, I think we need more work to explain their relationship. And sorry, I think.
Yeah,
sorry.
It's clear. Yeah, we know. Yeah, this is indeed a very interesting finding. If possible, we hope that there will be more breakthrough scientific finding from this human microbiome resistance, right, to COVID-19 virus.
Yes, we need more work to.
Yes. Okay, so in the chat we do have another question from Joey. So have interesting strains been isolated?
Isolated from where? From our sorry, can I see the questions?
Yeah, you can see the question. Yeah.
Oh, okay.
Yeah, it's in the chat box. You can see it. Yeah.
Interesting strains isolated from our intestinal tract or somewhere else, and we have currently in our lab, under the supervision of my professor Ho Chen Long, we study a bone microbiome and intestinal microbiome, and sure, we isolate many strains from the bone and the intestinal. For example, we isolate some soil-dwelling bacteria and some skin-dwelling bacteria, for example, S. aureus. But how they strains enter our bone, or how they get into our intestines, we don't know yet. But and how they infect our health, and we need more work. So I think this is where it's very complex to explain every detail, but we will work it out. Thank you.
Yeah, thanks for the answers. Yeah, it's still a long, more work to do to complete, right? Yeah. So we also have one question from Dr. Tian Hui San. So what changes in the COVID-19 microbiome did recovered patients have?
What changes? Some COVID-19 patients have increased opportunistic pathogens, and most importantly, the COVID-19 patients have the new invasion from the SARS-CoV-2, right? But there are also some other change from the, for example, from the intestinal microbiome due to the, and most importantly, no matter from the patients or the health volunteers, our microbiome changes every day, every minute. So it's very dynamic. But from static data, we can see that the most importantly, and most significantly is from the increase of some opportunistic pathogens, but some other commensal bacteria or fungi, they are inherently in our body. So they cannot, maybe they cannot reflect the real situation from the difference between the patients and the healthy volunteers. And the different reports, many different reporters have different results. Maybe they have some increase of E. coli or some increase of some other strains, but there are no agreement on the same bacteria. I think this is very, because our microbiome is dynamic, so it's very difficult to define which strain or which bacteria are increased or declined. Okay, thank you.
Yeah, thanks for Chunjun for the insightful answers. So if there's no more question, I think that's the all for the session. So thanks to Chunjun for your presentation again. Thank you.
Okay, thank you, Stephen.
Thank you. So ladies and gentlemen, with that, we have come to the conclusion of our symposium. We hope that the sharing sessions over the past 2 days have embedded in us the resilient mindset to chart our path forward during these challenging pandemic times. So before we end, we will now like to invite our symposium chair, the Honorable Dr. Kwan Seng Hao, to give his closing speech. So Dr. Kwan, the floor is yours.
Yes, well, every good thing comes to an end. It's almost 11, so I'll try to keep this short. Thank you for staying with us for these two nights. I hope you guys learned a lot. I hope you are able to extract lessons that from the speakers. Yesterday we brought you around the world, right? We started with Malaysia, and then we went all the way to Canada. We explored mining concepts, and then we went to Chile, South America. We looked at how Chileans are doing, right, under COVID, and the efforts that are underway in Chile. And then we looked at China in Guangzhou. Great things are happening there, interesting platforms to use for education. And then we moved on to Sweden, right? Sweden, and we saw how things are happening in Sweden, right? And today we came back to Malaysia, and then we took a tour to Thailand, and we looked at how over there they're making oxygen generators, right, to help remote hospitals. And then we also looked at topics like tropical disease, AlphaFold, so on and so forth, and also the talk before mine, the sharing from Chunjun from China as well. So I hope this has been a great experience for all of you. I want to thank all the speakers for sharing their insightful experiences with all of us. I want to thank you, audience, for staying with us for the 2 nights. It's been a great joy for all of us. Last thing I want to thank is the committee, right? The committee who made this happen. I want to thank Dr. Stephen and Dr. Kara for the great hosting, very good hosting. I was quite entertained. Also, I want to thank Dr. Stephen for his leadership and support as a co-chair for the symposium. I want to thank the secretariat, Dr. Xu, for handling emails and registration, as well as Dr. Tiam for handling our meeting minutes. I want to thank Dr. Sylvia for making the poster for our event, for making the backdrop, this beautiful backdrop at the back. It's made by Dr. Sylvia. I want to thank Mr. Tan for being a great host, doing the IT, playing videos and presentations. Great job. Also, I want to thank Dr. Amaris Singh for coming up with the program book. A lot of work went into the program book that you saw today, that you downloaded at the beginning of the night, right? A lot of editing went into that book. It looks simple, but it's actually a lot of formatting from different sources. Finally, I want to thank Dr. Karine for helping out with the promotion and helping coming out with the draft of our design of our poster, right? So thank you, everyone. Have a good night, right? Stay resilient, stay safe, right? Take care, all right? Bye.
Thank you, Dr. Kwan, for the closing speech. So once again, we would like to invite all distinguished guests, speakers, and participants to switch on your camera for photo sessions to commemorate this event. Please get ready for opening up your webcams. Yep, everyone, don't be shy. Come, please open up your camera so that we can have a group photo sessions together to signal the end of this event. Please get ready your most presentable pose, while our technical team will give the signals for the camera to be taken.
Okay, ready? 1, 2, 3. Again. 1, 2, 3. Okay, thank you.
Hey, thank you everyone again for your participation in this Resilience 2021 Symposium. And we hope to see you again next time.
Goodbye and stay well. Thank you.
Thank you. Stay safe, everyone.